Our use of land, at least globally, can be split up into four main categories: agriculture, forestry, mining, and urban areas. Of the entire planet, about 29% is land. The other 71% is ocean. Of all the land, only about 71% is habitable. The rest is difficult to occupy because it's glaciers or deserts or some other inhospitable area. Of all the land that humans could live on, we actually only take up about 1% of all available space, and that includes cities and rural settlements like towns and villages. But just because we take up only about 1% of the land doesn't mean we don't have a massive impact on how land is used. Of that available land, half of it is reserved for agriculture. And the other 49% is split between our remaining forests, grassland, shrublands, and the freshwater ecosystems like lakes and rivers. Globally, the majority of our agriculture is for the production of meat. The majority of crops we grow are not eaten by humans. They're eaten by the cows that, well, we eat later. This is mind-boggling considering 82% of the world's calories actually comes from plants. We use more than 3/4 of the world land area to feed animals, and those animals only account for about 18% of the global calorie supply. Seems a little inefficient. It's not much different in the United States. In the United States, the vast majority of land is also used for agriculture, split between croplands to grow crops and grazing land for animals. Let's take this graph and simplify it. What's interesting to see on this map is how much land is devoted to maintaining forests and grasslands, both of which are labeled as pasture in the graph. But I want to take a look at the politics of this a little bit. See, in the United States, there are two big federal departments in charge of managing land. The first one is the United States Department of Agriculture, or the USDA. That's in charge of managing agriculture, grasslands, and forests. Beneath the Department of Agriculture is the Forest Service, which is actually directly responsible for managing grasslands and forests. This is important because branches that report to the USDA are actually part of the Department of Commerce. Yeah, you heard that right. The largest environmental areas in the United States are part of the Department of Commerce. See, this is why grazing is allowed on federal-owned land and why logging is permitted in national forests. These areas are established to allow job formation and resources to be extracted from our natural areas. The USDA and Forest Service are mostly just there to make sure that it's at least done reasonably sustainably. The second government agency in charge of national areas is the Department of the Interior. Now, on land managed by the Department of the Interior, resource extraction is not allowed. And I mean no resource extraction. With very few and specific exceptions, you can't even remove a rock from these areas, or you'd face a fine, or in severe cases, even imprisonment. The Department of the Interior is the department that houses the National Park Service, which is in charge of national parks and wilderness areas. These areas are established for the conservation of ecosystems, well, for the sake of maintaining them and for the enjoyment of those natural areas by people, so you can go hiking in them. Now let's go back to the maps, but this time break it down by who is in charge of the land. Now we see a more realistic view of the US natural areas. It's the fraction of land in the top designated in blue. That's the land that's actually reserved for, well, protecting ecosystems. The land that's under the jurisdiction of the USDA is much larger and is utilized for the raising of animals for, well, burgers and the growth of trees for lumber. And to be fair, looking at the forest land, the majority of it is not even federally owned. Most of our forests are either privately or corporately owned. And better yet, one single owner, the Weyerhaeuser Corporation, owns a big portion of all forests in the United States. But we will get into the agriculture and forestry later. For the rest of this video, I want to focus on the urban land use. Land that we've built cities on is only about 3.6% of all land in the United States, but it is the fastest growing type of land use in the country, adding about 1 million acres of city every year. Globally, the majority of people live in cities now, and in the United States, urban populations are increasing, while our rural populations have remained virtually unchanged since the 1960s. This change, both globally and in the United States, has its advantages and disadvantages. One benefit of cities is housing density. Cities let more people live in a smaller area, freeing up more land for either agriculture or conservation. Cities tend to have a lot of apartments and townhouses, which reduces the total land footprint needed to house people. Look at this aerial view of a rural town. The houses are generally large and spaced far apart. Now, in the city, living units are pretty much spaced, well, right on top of each other. But there is something strange happening here. Let's take a look at the population density of Chicago. It seems to be decreasing slightly. And if we look at the population of Chicago, it's also decreasing. So how can the population of people living in urban areas be increasing if one of the largest cities in the world is seeing a population decrease? Now, let's take a look at how Chicago has developed. See, the city has kept expanding outwards. And as this happens, a new area was coined, the suburb. Chicago and most cities continue to sprawl outwards, and more people are choosing to live in the suburbs. Urban sprawl is the expansion of a poorly planned, low density, and semi-autonomous development which spreads out over large amounts of land, putting a long distance between homes, stores, and work. This urban sprawl pretty much negates the benefits of living in a city, as suburbs have much lower population density and thus expanding the footprint of urban areas. This ends up causing a few issues. People might live in the suburbs of a city but continue to work inside the actual city. This causes many traffic jams. But with all those people driving, especially as inefficiently as your car is in traffic, it makes suburbanites responsible for the majority of CO2 emissions. But this movement, aside from being an environmental disaster with an increase in CO2 emissions and the destruction of land for urbanization, it results in an economic issue as well. Urban blight is a process by which a city or parts of a city fall into disrepair. It results from a quick loss of population, which removes businesses and economic opportunity. For those who stayed, those people quickly face high unemployment and a lower standard of living. The lack of job opportunities here lead to high crime rates, which further serves to perpetuate the cycle. A hallmark of urban blight are the abandoned buildings and empty lots that we commonly see in inner cities. Now let's take a look at a few other issues of cities. Cities have a lot of surfaces that are impermeable to water. Things like buildings, roads, sidewalks, parking lots. These impervious surfaces don't let water reach the soil, which can result in quite a bit of extra flooding since the water has, well, nowhere to go. See, in a natural environment, water is absorbed by the soil and by plants. And about 40% of it ends up evaporating either from the soil or as trees transpire water out of their leaves. This leaves only about 10% of all rainwater to run off into nearby bodies of water. In cities, due to all the impervious surfaces, about 55% of all rainwater runs off into some nearby river or lake. But in cities, it's not just the extra water that gets into the rivers. I mean, think of all the stuff that is in cities, the trash and lawn fertilizers and oil from vehicles, even sewage, all ends up running off into the nearby water systems. But all these impervious surfaces also contribute to one other issue. See, urban areas are typically warmer than their surrounding rural areas, sometimes by up to 10 degrees warmer. This is the urban heat island effect. See, cities typically have more dark colored surfaces, which absorb more sunlight and radiate back heat. Cities also have fewer trees than rural areas. That's important because evaporation is an endothermic process, so it absorbs heat. So the lack of evapotranspiration from trees keeps more heat inside cities. This leads to an extra use of energy for air conditioning during the summer. And right now, the day I'm shooting this video, it's 97 degrees in Chicago. It is hot. So with all the issues involved in cities, what can we do to make cities more livable and in turn encourage movement back into cities? Well, one thing we can do is to plant more trees. The increased vegetation will reduce runoff and act to mitigate the heat island effect. On this map of New York, we can see vegetation cover. And then if you overlay the temperature map, you can see areas where the vegetation is densest, the temperature tends to be a little bit lower. We can also incorporate vertical gardening on buildings and encourage the use of green roofs. Both of which, aside from adding aesthetic value and a way to actually grow local produce, would aid in the reducing of the heat island effect. Smart growth is a way of developing cities with sustainability and livability in mind. The principles behind smart growth include incorporating lots of green spaces, using compact housing design that builds up rather than across. It seeks to make cities walkable so you don't need to drive around as much. And it's also important to preserve critical environmental areas, so when cities spread out, it doesn't get into potentially important habitat areas. And also, the one that a lot of cities really seem to struggle with is creating plans for high quality, accessible, usable public transit.